Sixth grade lesson 8.9 is writing inequalities. And for the most part, we just need to recognize which number is supposed to be the bigger one and the alligator mouth goes to that. Or which one's supposed to be the smaller one and the alligator butt goes to that. So that just takes a little practice, and this lesson is going to help us do that. Let's have a look at how this plays out. And what you'll find with these as you get further into translating these inequalities is you do kind of translate them in the same way that you do an equation. You kind of go through the same steps. You do go through the same steps. You read the question, read the whole thing, underline the question, circle information that applies, draw the picture that helps. You put it together the same way. The only difference is instead of using an equal sign, you're going to have to spend some think time to determine which of the two sides of what would have been the equation that is now an inequality, it's not equal, which of the two sides is going to be the bigger value. And so it takes a little bit of extra think time just for that. But otherwise, your skills that you're using to translate equations comes into play for translating these inequalities. Let's start with this one. The highest temperature ever recorded at the South Pole was 8 degrees Fahrenheit. Write an inequality to show that the temperature T in degrees Fahrenheit at the South Pole is less than or equal to 8 degrees Fahrenheit. Let me just back up a little bit and do a quick review on greater than, less than, the symbols for them. I think you remember the alligators. You have greater than or less than, and I know I'm one of those people that doesn't remember, is this the greater than, is this the less than? Doesn't really matter, because as long as you remember the mouth of the alligator is going to go eat the bigger value and the butt of the alligator is always pointing to the smaller value. So as long as you remember that, you're okay. You may also remember seeing that these signs sometimes have the equal sign underneath them, or half of the equal sign underneath them. It means that whatever value might be over here is a larger value than what's over here, or also could be equal to. Where if I just have this symbol, whatever's over here is a larger value than what's over here, but it cannot be equal to. So that's the only difference between them. So those are the symbols you'll use. If we've got is less than or equal to on this one, then we're using one of these with the little equal sign underneath, one of these over here. Okay, so I compare the two things. We've got the temperature at the South Pole, and we've got 8 degrees. And I'm going to go back into the question and read through for those key words of which one's supposed to be the bigger one, which one has the larger value. So the temperature T in degrees Fahrenheit at the South Pole is less than or equal to. The South Pole is the smaller one. The temperature at the South Pole is the smaller one. So if this is the smaller value, then the symbol that goes here has the butt facing the smaller value of the butt of the alligator. But it also said or equal to, so we'll put that under there. That means that whatever this number is, it could be an 8 or a 7 or a 6 or 5, 4, 3, 2, 1. Could be numbers in between, like a 6.5, right? It could be all kinds of possibilities. But whatever it is smaller than or equal to 8, not larger than. And there's those answers. Look in the book what they're looking for right there. Okay, let's see another example. Let's read it. The directors of an animal shelter need to raise more than $50,000 during a fundraiser. They need more than that. Write an inequality to represent the amount of money, M, in dollars that the directors need to raise. They need an amount of money, and it is going to be compared to the $50,000. But it said they needed to raise more than that. So I asked myself, sometimes I draw these boxes too. For some reason, it helps me. I have M, I have 5,000. Which one is supposed to be the larger value? They need more than this amount of money. So whatever M is, it's got to be larger than that. So M is the larger value. So the alligator goes towards that. Alligator wants the bigger value. And it doesn't say more than or equal to. It doesn't say at least they need 50,000 or more. It just says it's got to be more than. So 50,001 would work. Even $50,000.50, right, would work. So whatever this is, though, it needs to be more than. So that is your inequality. M needs to be greater than $50,000. Okay, a couple more examples. Probably starting to feel like this is more language arts than it is math. In some ways, it kind of is. You're right. We have the weight is less than 3.5 pounds. So we're comparing the weight W to 3.5 pounds. That's what we're comparing. And I do my boxes for whatever reason. My brain likes that, so I do that. I'm comparing W and 3.5. Which is the larger value? Let's go back and read it. This weight, whatever it is less than. This has to be the smaller value. Smaller. So it will look like that. And it just says it's less than. It doesn't say less than or equal to. It is less than. So whatever W is, it could be 2, it could be 3, because this is 3.5. So it could be 3, it could be 2, it could be 2.5, it could be 1, it could be 0, right? It could be a whole bunch of possibilities. What we do know is that whatever it is smaller. It is less than 3.5. There must be at least 65 police officers on duty. Okay. So the phrase at least is equivalent to is, it's got to be more than or equal to. And again, my silly box, I don't know why. I have a number of officers. Did they give us a letter? Yeah, they said P for that. And 65 is what I'm comparing. Does this number P need to be bigger than? If I have to have at least 65 police officers, does that mean this needs to be more than 65 or less than 65? It means at least 65 is the minimum I can get, and otherwise it needs to be more than that. So this number, this value, whatever it is going to be the larger one. But at least also means it could be that, and that's okay. So equal, it can also be that. So police officers compared to 65, it needs to be at larger than 65, or it could also be equal to. So where P is a whole number, I think that's what they want there. You really do want this one to be a whole number and not a fraction, because these represent police officers, and so having a fraction of a police officer show up is probably messy. So you want a whole per police officer, a whole person there. So I think that they want a whole number there. I'm not sure. Yes, that's what they want. Explain why the value of P must be a whole number. It's a person. Fractions and decimals of people is not good, remember, because fractions and decimals are a portion of a whole. And so cutting people in portions is messy. Don't do that. Okay, final example is now going in the reverse and saying, what does this really mean from Matthews into English? So what we're looking at is n, this unknown number. It's looking at the alligator butt. That means it's a smaller value or equal to this 0.3. So n is less than, it's smaller than, or equal to 0.3. We could also say n is no more than 0.3. Whatever it is, it can get to 0.3, but it can't go higher than that. It's got to stay smaller. All right, over here, we have A, and here he is facing the alligators coming at him. That means he's big. He's bigger than this anyway. A is larger than, or A is more than -4. There could be other words you put in there. So like I said, you're looking at kind of just the language piece to this for this lesson. Which one represents greater, which one represents less, which is a value that is greater, which is a value is less. So you're just figuring out that language piece to it. Takes a little bit of practice. This lesson gives your brain the time to practice that.